So in this section, I would like to look at some of the features of Voynichese and compare them to known meaningful language texts and see in what ways Voynichese seems to be very strange and in what ways it seems to be more typical. So to start with, how is Voynichese unusual compared to other language texts? The character set size, the number of characters depends on what transcription system you're using, about assumptions you make about which glyphs represent single characters. But regardless of these assumptions, the character set size is about typical for an alphabet. And in fact, the frequency distribution of characters looks like what we would expect for an alphabet. However, if you look at characters in sequence, the text looks a lot more unusual. If you look at the conditional character entropy, it's unusually low in Voynichese, a little bit lower in Voynich B, but in both cases it's a lot lower than we would expect for a text, and this indicates that at the character level the text is extremely predictable. And so to see what I mean, look at this this chart. We've compared Voynich to 311 different language texts. These were compiled from Wikipedia versions of different languages, and so each dot represents a different language text. The blue dots are all text written in alphabets, and so you can see they are the closest to Voynich. Abjads are tend to have a little higher conditional character entropy. These are like Arabic and Hebrew. But these are all a lot closer to Voynich than the other script types. So here we're going to take this chart and zoom out a little bit to look at a character set size that goes up to 130, and this includes most of the abugidas, a lot of the index scripts, and a few of the syllabaries, where each character represents a syllable rather than a phoneme. Here you have a higher character set size and a little bit more conditional character entropy. But zooming out again, on the extreme end, you see the other syllabaries and then logograms, where a character represents an entire morpheme or an entire word. And here you have the highest levels of conditional character entropy and the largest character set sizes. So Voynich looks most like an alphabet, but it is still very unusual in just being having extremely low conditional character entropy. Now, a lot of this predictability is word internal, and it stems from the fact that certain characters and character sequences are very, very commonly found in particular parts of the word. So these are some generalizations. This isn't the entire character set, but these are some of the major generalizations about how words are constructed in Voynichese. And you see that there are these word final characters and word final sequences. And then there are these characters that are almost always found in the middle of words, and then these sequences that are almost always found at the beginning. And this is similar to what we find with abjads like Arabic, where there are word initial forms of a character, word medial forms, and word final forms. But this is an extreme example. So for example, these 5 word final sequences are found in 90% of all Voynichese words. And so 90% of Voynichese words end with one of these sequences. And about half of the words begin with one of these sequences. And so this this is more extreme than we find with abjads, and it's not doesn't seem to be only related to single characters, but also what might be considered character sequences. Um, and there are some character sequences, these two in particular, uh, which are found much more commonly in Voynich B rather than Voynich A. And in fact, just the difference in frequency between these two sequences can account for the difference in conditional entropy between Voynich A and Voynich B. Voynich B is a little bit more predictable because these sequences are just that much more common. And beyond the level of the word, there are certain characters which correspond to particular places in the page. So some characters are almost exclusively found as the last word on a line. And these characters are probably variants of other characters. I say that because of a resemblance and because they are usually found as the last word in words that are very commonly spelled differently elsewhere. So I think that we can have some level of confidence that these are word final, or rather line final variants. So this is the way that you write this character if it's at the end of a word, of a line rather. And secondly, there are these characters which are also found within words, but may be found at the beginning of a word. And in this case, they are almost always marking the beginning of a paragraph. So most paragraphs in the text are demarcated by having one of these four characters and followed by the first word of the paragraph. So these are examples of character variation that maybe seem more like punctuation. They seem to be demarcating something about the text, the space in the text, rather than something about the word itself. But so putting it all together, Voynichese at the character level is extremely predictable. There seem to be these positional variants where within a word, certain characters and character sequences are only found. And like I said, in some ways this resembles like an opjod. In some ways this resembles punctuation. But this is a very extreme example of this predictability. And another possibility for this predictability is that the language that is being used, that the writing system, the Voynichese writing system, is losing some of the phonemic distinctions of the language it's intended to represent. So, for example, the languages that have the highest, or rather the lowest conditional entropy in our sample, the ones that are the closest to Voynich, are alphabets written in the Latin script, but that are writing languages like Tibeto-Burman languages, or some Niger-Congo languages that have tone that might or might not be represented in the orthography. So languages like Chinese and Japanese were not included in this because they are not, because morphemes do not distinguish, spaces do not distinguish words. But so we look particularly at the Tibeto-Burman languages that have that are written in a Latin script. And so, yeah, another example is these Polynesian languages where there might be a length distinction that is not represented by the script, a vowel length distinction. And these languages may also just have a smaller phonemic inventory. So it's possible that something similar is going on with Voynich. Another issue is that, like I said, we might not be entirely correct on what we've decided are particular characters. What glyph sequences count as single characters? What are the boundaries of glyphs that represent the characters. And I think that if these issues are settled, then there's a potential that this could explain some of the predictability in the text. However, counter argument might be that it's all just evidence that this is meaningless. This just doesn't look like meaningful language, and yeah, and so this is likely to be gibberish. However, if you look at the word level, you don't look at how things are spelled, but consider each word to be a separate entity. These statistics tend to look more like what we find in our sample of natural language texts. Voynich becomes much less of an outlier, and so these include things like word level entropy, both absolute unigram and bigram conditional entropy look like within the range we find in these other texts. Word repetition, meaning the exact same word spelled the exact same way as in complete reduplication, is it's somewhat high in Voynich, and if you look at the text, it looks sort of repetitive in that way. However, exact word repetition is not. It's not as much of a. It's not a complete outlier. It's within the range we find in our natural language sample. It's a little bit high for European languages. It's high for historical texts, but it is not as much of an outlier as this complete outlier we find with the conditional character entropy. And also the most common word, the percentage of the text taken up by the most common word, is also something that is within what we might expect for natural languages. Voynich A, this word that might be transcribed as dine, is a little bit less than we find for the in English, in terms of the most common word being percentage of the entire text. And then Voynich B, this word chady is the most common word. It's about half as common, but this is all still, this is within what we find in a broad range of text. And in addition to this, the frequency distribution of words in Voynich seems to follow a Zipfian distribution. This is a power law in which the first ranked word is about twice as common as the second ranked word, which is about twice as common as the third ranked word, etc. And so Voynich definitely seems to be following this distribution. Voynich B is a little bit of an outlier because the first three most common words in the text are all roughly the same proportional frequency. So that's a little bit unusual. Something that I find interesting here is that there's a very big difference if you consider this character called a plume in Voynichese. It looks like a little apostrophe, and it's much more common in Voynich B. The Voynich B scribes use it a lot more, and if we consider that it has some function, either it's optional or it has some function that is not word related. If you take them out from both, they actually the two languages look much more similar, Voynich A and Voynich B, and they look very much like what we would expect a distribution for a natural language text. Two other measurements that we've been looking at seem to roughly correlate with morphological complexity, by which I mean whether a language is more isolating or more agglutinating, whether a word tends to have only one morpheme or multiple morphemes in it. And the first of these measurements that we've been looking at is the moving average type token ratio, which is the type token ratio under a particular window of words averaged over over this window throughout the text. We found an optimal window to be about 2,000 to 3,000 words. And here is a distribution of this statistic in a few selected language families. Note that Germanic and Romance are sort of mid-level morphological complexity. We've taken Polynesian as an example of a more isolating language, and or rather language family, and Turkic as an example of a more agglutinating language family with more morphological complexity. So you can see that matter seems to correlate, higher matter seems to correlate with more morphological complexity, and Voynich seems to be in the mid-range here. And in fact, this little outlier you see in the Romance family is the sample of Latin. Latin was included in the Romance languages in our sample because there are not a lot of historical texts, but it would be more accurate to separate it, and it is in fact, as you might expect, more morphologically complex than the modern Romance languages. And this is what we see in the chart here. The other thing, the other measurement we've been looking at is the proportion of the text taken up by the most common words, a certain number. So 25 we found is a good number. So the 25 most common words and how much of the text is taken up by these words. And there is an inverse situation here where the more morphologically complex languages tend to have a lower distribution, because the most common words in these languages will take up less of the overall text because of things like there might be gender distinctions. So if a word like has multiple gendered forms of a determiner, and a determiner is the most common word, then that sort of spreads the distribution out. So this is a similar situation. We find Voynich patterns a little bit more like Germanic and Romance, and Polynesian and Turkic are outliers. And if we chart the most common word percentage against the matter, we find this this correlation is more visible, where the most morphologically complex languages are on the upper left here, and the least morphologically complex languages, the more isolating languages, are found on the bottom right. Tibeto-Burman is kind of a tricky example. It's sort of tricky because only certain scripts, as I said, we can only take certain scripts because others do not represent words on the morpheme level, and but we see on the far right here the Creole languages, which we've put into a distinct category regardless of the language family of the lexifier language, so, as you might expect, these are the more isolating languages. And Voynich is in the mid-range again. In fact, it's a little bit closer to the mid-range and a little bit farther from Germanic and Romance, closer to Indic and Iranian. And I don't think that this tells us it's more likely to be Indic and Iranian. I think that Germanic and Romance are just as likely categories, but something like Inuit, for at least a couple reasons, is very unlikely to be the underlying language of the Voynich script. But, you know, even the Turkic languages, the Kartvelian languages, the Caucasian languages are probably not candidates. So at the character level, Voynich is extremely predictable and constrained. It does not look a lot like natural language. At the word level, however, it looks a lot more normal. there's evidence of language-like structure. Um, and in fact, there's measurements that suggest that Voynich is a medium level of morphological complexity, maybe more like Germanic languages or Indic languages. Um, some morphological structure, but maybe less than something like Latin. And so the question is, could a meaningless text contain all of these properties, contain this structure? If Voynich is gibberish, how is it constructed in a way that preserved what we'd expect of a natural language text?